Hi everyone. So these videos are meant to help you with the Chapter 9 section of the Algebra 2A second semester exam. This stuff was the longest ago. It was the very first stuff we did in semester 2. And it was the most algebraic and probably the most complex. So don't feel bad if there's some of this stuff that you're struggling with a little bit. We just have to make sure to remind you of all of the stuff that you were so good at the time. Okay, so looking at this first one, find the quotient and the remainder. Now, there's actually a shortcut we could have taken if it just asked us for the remainder. But because it asked us for the quotient as well, I am going to end up having to do some long division here. So here's how long division works. The x minus, was that an x minus 1, goes on the outside. And this big thing, 4x to the 4th plus 3x cubed minus 2x squared plus 4x minus 1 goes on the inside. And remember that if any of those pieces had been missing, you want to make sure you have every possible, exponent for x. Any of them had been missing, you would want to put a 0 in their place. So now we're going to say to ourselves, x times what makes 4x to the 4th? Well, that would be 4x cubed, because 4x cubed times x would give me this. So up here above the x cubed, I'm going to put 4x cubed. And now I'm going to multiply. 4x cubed times x is 4x to the 4th. And that better work out correctly because that's how we planned it. And then 4x cubed times negative 1 gives me negative 4x cubed. Now the thing to remember about this next part is that what we're doing really is subtracting both of these. Okay? So this cancels out, and this is really 3 minus negative 4, which is 7x cubed. And then you want to bring down the negative 2x squared. And now we're going to repeat the process. So x times what makes 7x cubed? Well, that would be 7x squared. Okay. So 7x squared times x is going to give me, let's see, I'm going to take this up here, I suppose. So this is what we had, 7x cubed minus 2x squared. I'm going to have 7x cubed minus 7x squared, and then I'm subtracting all of this. That's going to cancel, and negative 2 minus negative 7 is really negative 2 plus 7, so that's 5x squared. I'm going to bring down my 4x next. Okay, so x times what makes 5x squared? That would be a 5x. 5x times x, 5x squared. 5x times negative 1 is negative 5x. Subtract. Gone. 4 minus negative 5 is positive 9. Okay, so 9x, and then I'm bringing down my negative 1 from over there. Okay, and then I'm saying to myself, x times what makes 9x? That would be 9. And that's going to be 9x minus 9. Subtract. Negative 1 minus negative 9 is really like negative 1 plus 9, which is positive 8. So I would say that this is my quotient up here, okay? And this is my remainder down here, okay? If I was going to put it all back together as one answer, I would write this as 8 over x minus 1 and tack it on to the end of that. But the way this question is worded, it kind of asked me for them separately, so I'm giving them separately. Okay, well, that was a tough one to start out with. But okay, this next one. If q is a polynomial and q of negative 4 equals 0. Now this right here is telling me that negative 4 is a root or a 0. Remember, those words really mean the same thing. Okay? Negative 4 is a root slash a 0. Then what would a factor be? Well, the factors are always written as x minus whatever the root is. So we would end up doing x minus negative 4, otherwise known as x plus 4. Okay, number 3. Approximate the smallest x-intercept of this graph. Well, I'm going to want to look at a graph. So let's go to my y equals, and I'm going to type in x cubed minus 4x squared plus x plus 1. Hit graph. Okay, and my smallest x-intercept is the one that's farthest to the left, okay? So that would be this guy right here. I'm going to change my window a little bit. I got a lot of dead space over here and even a little bit over here, so I'm going to shrink up my x's and have them go from -5 to 5, just so I can see a little better, okay? And so we want this root right here. What I'm going to do is I'm going to use the calc menu, and I'm going to go to calc 0. Okay, now it's asking me for left bound. Keep in mind that I'm looking for this 0 here, so I need to move my cursor somewhere to the left of that 0. This is what I'm trying to find. So I'm somewhere to the left, doesn't matter how far. Hit enter. Right bound, so I want to move back to the right until I'm somewhere past that point. Enter, and then hit enter one more time, and it tells me that that is at -0.377. I believe this just asked me to go to the nearest tenth, so I would say, I'm just going to write on here, from the calculator, that x is approximately equal to -0.4. Okay, and that's all you have to do for that one. Okay, number 4, factoring something like this. Now, there are a couple of alternatives, and I'll kind of discuss those after we're done here. But when we learned how to factor something like this, the first thing we would ask ourselves, is there anything I can divide out of all 3 of these? And in this case, there's not, but you should always look for that first. So now I'm going to go 10 times 14 is 140. And then I'm looking for a combination of numbers that multiplies to this 140, but adds to this -39, okay? And I believe we came up with, if you go through all your ways to multiply to 140, this is equal to 5 and 34. Let's see. Oh, I'm sorry, 4 and 35. I knew it was something like that, but if you couldn't come up with that off the top of your head, because I don't expect you to, I just am cheating because I did this one in class, start making a list of all the ways to multiply to 140 until you stumble across one that also adds up to 39. Now, the fact that that's a -39 means I want to use 2 negatives here, because 2 negatives multiply to make a positive, but they add to make a negative. And now what I'm going to do is I'm going to rewrite this whole expression, except I'm going to replace the -39 in the middle with these 2 numbers. So I'm going to say 10x squared minus 4x minus 35x plus 14. And then I'm going to factor by grouping. So I'm going to take these 2 together and these 2 together and pull out whatever greatest common factor they have in common. So out of these 2, I can pull out, let's see, a 2 and an x, and that would leave me with a 5x and a -2. Here, these 2 have a 7 in common, and I'm going to pull out a -7 because I know that I want my final parentheses to come out negative, and right now that's a plus. So if I pull out a -7, then I'll be left with a 5x. And if I do 14 divided by -7, I have -2. So now, here's how this becomes actual factors, is one of your factors comes from this twin parenthesis, right? So you get 5x minus 2. And the other one comes from these 2 leftover numbers. And then it would be 2x minus 7. And if you FOILed those things back together, it should turn back into this original. Okay? Now, quick alternatives here if you were in a crisis situation on an exam. What you could also do with this is find the roots through like the quadratic formula. Okay? So you could use quadratic formula and find that the zeros, let's see, they would be at +2/5 and positive 7 over 2, and I'll tell you how I know that in just a minute. But that's what quadratic formula would give back to you. Now, you're going to have to be careful because if you're using your calculator, it's going to give these back to you as a decimal. And for this next step, you're going to much prefer them to be a fraction. So you may have to turn them back into fractions yourself. Okay? And so then we can say, well, we know our two factors must be x minus 2/5 and x minus 7/2, because remember what we talked about a minute ago, if you know the roots, right, the factor is always x minus the root. But we can't leave this like this for a couple of reasons. First of all, we don't ever factor with fractions, okay? And secondly, if I multiply this back together, I'm only going to get an x squared back in front, not a 10x squared. But what you can do is you can grab these denominators and slide them over in front of the x, okay? And that would give you 5x minus 2 and 2x minus 7. So that's an alternative, okay? This is another way to do this same kind of problem if you weren't sure how to do the factoring part. With factoring, there's always a workaround. If you can find the roots, you can turn the roots into factors, okay, using this method up here, okay? So either way you want to go is fine with me on that one. All right, let's take a look at number 5. We have x to the 6 minus 9x4 minus x squared plus 9, and I want to know, is it true that f of negative I is equal to 0? Well, what that means is I'm plugging negative I in for x, okay? So in my calculator, make sure to wrap it in parentheses. I'm going to go and, whoops, and I forgot the negative. Negative I to the power of 6 minus 9 times negative I. By the way, the I button is down here on the decimal point key. That's what I keep pushing down there. To the power of 4 minus negative I squared plus 9. And it does come out to be 0. Okay, so true or false, this is true. Okay, we plug that in and it does in fact equal 0. Okay, so now it says find me all the zeros. Okay, so first off, we really should be able to account for 6 zeros. And right off the bat, I know that I and negative I are going to be zeros. And that's because we just found that negative I is a 0. And remember that complex numbers always travel in pairs, okay? So both of these have to be zeros of this function. So now we're down to 4. Okay, we're down to 4 other ones that we have to find. Let's see what our graph tells us. Okay, so I'm going to go into my y equals and I'm going to graph this thing and see how many of the zeros I can take straight from the graph, because that would be very helpful. Remove that. X to the power of 6 minus 9x to the power of 4 minus x squared plus 9. I'm going to do just a standard window. Beautiful. I can see 4 zeros here. Okay. I can see, let's see, this should be at -3, -1, +1, and +3. I believe if I'm seeing that correctly, I have old lady eyes, so I'm going to check my table. So right here at -3 and at -1, I see that my value is 0, +1 and +3. Okay, so those are all zeros of my function. So I've got those two, and then from my graph, I'm seeing -3, -1, +1, +3. Okay, so as a final answer, all 6 of my zeros would be -3, -1, +1, +3, I, and -I. Okay, those are my 6 zeros. Now, if for some reason we weren't able to get all 6 off the graph, okay, what you would have to do is turn whatever ones you did have into factors and then divide this thing by whatever factors you're working with, okay? And then you should be able to use quadratic formula or something similar on the rest, okay? But this one worked out nicely that it just came right off the graph for us. Okay, I'm going to go ahead and call it good on this video because this is already getting pretty lengthy. And I will just pick up a second video with probably the next page.